In this video, we're going to talk about drawing and solving series circuits. So we looked at series circuits in terms of actually connecting everything through, seeing the light bulbs light up. We talked about how series is one loop. Everything is connected to the one loop. In terms of cake, the idea of series is that there is one cake. Yeah. Birthday cake. You have one cake and everyone needs a piece of the cake. So depending on how many people you invite to the party determines how many slices you get. This is how series works. The more components you add onto a series circuit, the less voltage each component is going to get. That's why the lights are dimming. So let's draw what this looks like. It says draw a series circuit connecting two resistors to a battery. So the first thing I would do is realize that a series circuit means that there's one loop. So I would go ahead and draw my one loop. We're going to draw it like a box. Here we go. So one loop. We need to put in two resistors and a battery. So I take my eraser, take out a spot there. So battery, and then 1, 2 resistors. Now, does it matter where I put everything? No. By convention, to make it easier for me to think about it, I always put the battery on the left side. So battery is short line, long line. So there's our battery. The two resistors are squiggle lines. So squiggle and squiggle. Now you could put them both up here, you could put them both right here, you can put them both down here, you put one here and one here. It doesn't matter as long as both of them are in the loop. So now we need to put all of our measurements on. So we measured across the battery with the multimeter. So we're going to measure across the battery with a multimeter. And this reading is going to be 9 volts. So this battery has a potential of 9 volts. The resistors are 100 ohms and 300 ohms respectively. So this first one is going to have a multimeter that reads 100 ohms. There we go. I could also draw it on the outside. And then this one has a multimeter reading of 300 ohms. And that's everything from this example. So we have one battery connected to two resistors in one loop. The battery has a voltage of 9 volts. This resistor has a resistance of 100. This resistor has a resistance of 300. All right, second example. So again, we're going to start with a series, which means it's one loop. So let's connect one box. There we go. We have 2 light bulbs and a battery. So that means we have 3 components. Battery's going to go here. And then, why don't I change it up? Put one here and one down here. Again, it doesn't matter where you put it because it's all in the same loop. All right, the battery is little line, big line. There we go. And the light bulbs, I'm going to do the little heart looking thing. There we go. There's one light bulb. And there's the other light bulb. Now you could draw this one pointing out. Doesn't matter as long as the symbol is on there. All right, the 2 bulbs are 600 ohms and 500 ohms respectively. So we have one here that has a multimeter attached. That is 600 ohms. And this one has a multimeter attached. That is 500 ohms. All right. Now it says the current through the circuit is 0.005 amps. Well, whenever we were measuring current, we had to include the multimeter in the loop. We had to force the current to go through the multimeter, so it had to be part of the loop. So the way we do that is we make a break in the loop for the multimeter. Okay. So this is the only one that doesn't have its own little box like this, is the current. So this is 0.0055 amps. So current has to be in the loop. All right, now why are we doing all of this? Well, it's because we'd like to be able to solve these. You know, if we connect all this stuff up, then how can we actually determine what's going on? So here's one where we have to draw it, and then we have to solve for something. So here we go. Series is one loop. See, we have two resistors and a light bulb with a battery. So 1, 2, 3, 4 components. So 1, 2, 3, 4. All right, battery, two resistors. So squiggle, 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 and squiggle, 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 and a light bulb. Heart. There we go. The voltage of the battery is 1.5. Okay, so that is measured across the battery. So 1.5. The two resistors are 150 and 200 ohms. Okay, so this resistor is 150 ohms. And this resistor is 200 ohms. Yeah. The current is 0.002. All right, so we know what the current is. So let's make our multimeter inside of the loop. There we go. And that's 0.002 amps. All right, so here's our drawing. We have two resistors, a light bulb, and a battery. Voltage is 1.5. The resistors are 150 and 200 ohms, and the current is 0.002. So the first thing we want to know is, what is the total resistance? So here's where setting something up like this would really, really help. And the examples you're going to work initially are going to have these, what I call Sudokus. So you have 1, 2, 3 components. Those components each have a voltage associated with them. So the idea is this one has a certain slice of our battery, this one has a certain slice of the battery, and that one has a slice of the battery. So we have V1, V2, and V3, our three components. They all have to share the total voltage. The total voltage here is 1.5. That's given. Then the current goes through all of the components. So there's a current through the first, current through the second, current through the third, and then there's a total current involved. Now what we discovered is one loop, one current. You cannot push a lesser amount of current through here than here. It's all got to be the same. So these are all the same, 0.002, 0.002, 0.002, and 0.002. They're all identical. The last thing we need to worry about is resistance. So R1, R2, R3, and then RT. So we're given 1 and 2, so that's 150 ohms and 200 ohms. So that's everything we know. To solve this, the easiest way to do it, purple, is figure out where you can find some information. So here we've got two knowns and one unknown. Two knowns and one unknown. This one we only have one known, two unknowns. This one we have two knowns and one unknown. Well, the first question is total resistance. So here, well, we can't solve it this way, so we have to solve it this way. The relationship is V equals IR. So 1.5 equals 0.002 times R, 5 by 0.002. So see how you're just going to fill in all the other information. And so the resistance, 1.5 divided by 0.002, gives you a total of 750 ohms. All right. So we did this one. Check. Next, what is the resistance in the light bulb? So we need to find R3. Well, we don't have this, but we now have all of this information. And so we know R1 plus R2 plus R3 equals RT. So 100, 150 plus 200 plus R3 equals 750. So if you do the math here, this is 350. Subtract 350 over and you get 400 ohms. Nice. So now we know the resistance in the light bulb. That's 400 ohms. So the last one is, what is the voltage across each resistor? Well, it can't be 1.5 because we have to share the cake. So let's share the cake. We have I and R. V equals IR. So it's this times this, which gives you 0.3 volts. This times this gives you 0.4 volts. And just for completion's sake, let's do the last one. This times this gives you 0.8. And the way you can check yourself is add these up. 0.3 plus 0.4 plus 0.8 gives you 1.5. So it's a great way. These little charts can help make sure that you're doing it right because everything should add up. Everything should work out for all of the blanks.